Hello, good morning. Thank you for watching the EMEA online summit for AWS. In this session, we are going to talk about encryption, the encryption that we, AWS, are doing without you having to configure anything. It's transparent for you, but also the many encryption options you have for different AWS services, or even the encryption inside your application where you want to encrypt data on the client side. My name is Sébastien Stormac. I'm a developer advocate in the AWS EMEA team. I'm based in Paris, in our AWS office in Paris. So if you look at a typical application, a typical infrastructure, there are many layers inside an infrastructure, from the physical network up to the application. This gives this type of lasagna diagram where we can talk about encryption at the storage level, at the network level, different types of network, VPN, VPC, but also client-side encryption, the encryption that you can do inside your application, and the SDK that you can use to help them, high-level libraries that you can leverage inside your application to encrypt your data. And you will notice on the side there, AWS KMS. AWS KMS, it's a fully managed service, more about that in a minute, to manage your keys, because of course encrypting data is good, but keeping your key secure, encrypted, audited, it's even better, and that's the service that allows you to do so. I'm going to dive deeper into that in the first part of this presentation. So before going into KMS, let's recap a bit about encryption, at least encryption with symmetric key. So it's the same key used to encrypt and to decrypt your document. Let's say you have a key, call it a data key, and you have your document to encrypt. So by combining the two with an algorithm like AES, for example, Advanced Encryption Standard, you can create an encrypted data document that can only be decrypted with the corresponding data key, the same data key. But then you wonder, what are you going to do with the data key? Because if the data key allows to decrypt your document, you need to protect that data key. It has to be a secret. So best practice is usually to encode that data key itself with another key that we call the master key. And so the combination of the data key encrypted with the master key, it's the encrypted data key, and you can safely store your encrypted document and your encrypted data key together, because the data key is encrypted, so nobody can use it unless you have access to the master key. And to keep these two elements into one file, typically you need to have a kind of envelope structure. It might be a binary envelope. If you're using Amazon S3, you can use the metadata of Amazon S3 to store the encrypted data key. So you have the object, the encrypted file itself, and then the metadata contain the encrypted data key. But then you wonder, how can I protect my master key? And that's a perfectly legitimate question to ask. What are you going to do with that master key? If you want to protect it, it has to be encrypted as well. And this is where a service, a key management service, enters into the game. That service has its own master key at the service level, at the region level. So you can encode your master key with a service master key and to keep it as an encrypted master key. And depending on the service you're using, it might be multiple service level master key, and create a chain of encryption until the root key, which of course has to be protected, probably in hardware security modules. So that's the basic idea of a chain of keys and the different levels of protection that you need to apply to your key. So let's go back to AWS Key Management Service, KMS. It's a fully managed service to create, to verify, to rotate, to delete, and to use your key. Fully managed means that you don't have to install anything. You do not need to create an Amazon EC2 instance for it. You don't need to install, download, patch anything. It's a service that you can use through our API. And the service is integrated with many other AWS services. So you can actually ask Amazon S3 to leverage a key provided by KMS. I will talk about that on the next slide. You can also define IAM, Identity and Access Manager policies, to define who has the right to generate a key, to delete a key, or simply to use a key. So you can use a different security profile, different roles, depending on the application, to define what key an application can access, if any, or just plain disable access to to KMS for a specific application. The usage of the API, just like for any other AWS service, is monitored through CloudTrail. So at any moment, you can actually monitor who, what API, what service, what user, what role is using the API. So you can monitor the access to your keys, and you can prove that your security posture, that you are compliant with your security posture. AWS KMS can also perform some very small encryption. I say small, it's on small document. So you can also delegate a plain text document to KMS, and KMS will encrypt it for you, decrypt it for you, or generate a signature for you, for example. And KMS, it's a regional service. So it lives inside a region. It means that the key is only visible, it's only available for your application inside a specific region. Let me give you an example of integration with another AWS service, integration with Amazon S3. So historically on Amazon S3, you had the option to use server-side encryption where Amazon S3 was managing the key on your behalf. But since KMS is available, now you can also integrate Amazon S3 with KMS, and you can tell S3, hey S3, please use my customer master key managed by KMS over there to generate data key to encrypt the object I'm going to send you. So it's server-side encryption, but with keys that are managed by KMS. And you have two options. Either you choose the first one, Amazon S3 managed key, the historical option, I would say, and AWS KMS, where Amazon S3 just delegates the key management to AWS KMS. And Amazon S3 is not the only one. There are many services, more than 117 different AWS services that can leverage keys managed by AWS KMS. So the list is there. It's quite difficult to maintain that slide actually. I hope I didn't miss any service there, but you can see there Lambda, DynamoDB, RDS, SageMaker, and many other AWS services. So it's very important to understand the hierarchy of keys. I start to explain that in a generic way a bit earlier, but let me come back on that. So inside KMS, we are using a two-tier hierarchy for your customer key. So you generate unique data keys to encrypt your content. And that's very important. Each key that you use to encrypt a piece of content should be unique. And these keys, these data key, are encrypted with your customer master key. So it's your key. So in the KMS console, you can create a key, delete a key, assign permission to use a key. And using the API, the CLI, or one of our SDK, you can just generate data key. I will show you an example of with code just after. The reason why we are making that separation between individual data key for individual documents and the customer master key, it's because it's much easier to manage access, to manage the policies, and to audit access to a couple of master keys rather than millions, maybe possibly billions of documents that you are going to encrypt with a unique key. It also helps to mitigate the impact of a compromised key. Remember, the data key typically is stored with the document. Imagine that a bad guy is doing a brute force attack on that data key and manage to get a clear text version of the data key. It will be only one data key and not all the data keys used to store all the files of your application. So that way you keep centralized control on who is using your keys and an audit on who is using your keys. And of course, you can have multiple customer master key per application, per domain. It's up to you to decide. And each AWS service that is integrated with KMS will manage its own customer master key. So there will be a master key for EBS in that region, for S3, and for many others. You might wonder how we protect your customer master key. Actually, we are protecting it by encrypting it with a service level hardware security module backing key. So inside KMS, we have hardware security modules. You know, these security modules that you cannot physically tamper with. If you try to open them, it destroys the content of the memory. So all keys, the KMS keys, are stored in these type of hardware security modules, and we are using these HSM backing keys to encrypt your customer backing keys. And we have several levels of keys inside KMS. The HSM backing keys, but also a domain level key to encrypt the HSM backing key itself. So we have multi-tier inside KMS as well. Let's take a code sample and see what it means for you as a developer to actually use client-side encryption with KMS. The example here is available on my GitHub. I will give you the address in a minute. And it's using the plain Boto 3 SDK. So Boto is the Python SDK for AWS. So I'm also using in this example a third-party library to encrypt that gives me an implementation of encryption algorithm, and I choose for this example to use AES, the American Encryption Standard, for encryption. The code is in 3 parts. You see the 3 blocks on the screen. On the first part, I generate a data key. Remember, before encrypting a document, you need to have a unique key, a data key, to encrypt that document. So I'm calling an API on KMS, generate data key. I give 2 parameters to that API. It's the reference to my master key. So what will be the master key that will be used to encrypt that specific data key? And it's an ARN of a key that I created previously, maybe in the AWS console, or you can create that key programmatically as well. But it's just a reference. It's not the master key. The master key is never leaving KMS. I also give the key specification. So for what type of algorithm I want to use that key, please refer to the documentation to see the list of key spec that we do support. The return of that call is 2 components. And you have the plain text version of the key and the ciphertext version of the key. So if you want to store the ciphertext, you do not need to encode it or to ask KMS to encode it in a separate operation. Immediately, the result of generate data key, it's the clear text that you can use to crypt your data, and the ciphertext version of the key that you can use to store the encrypted document. The second part of the code is totally independent of AWS. It's plain old AES, where I give 3 parameters, as you can see, the key, the clear text version of the key, the type of padding mode I want, it's one of the algorithms of AES, and an initialization vector. Here my initialization vector, it's hard-coded. In reality, it will be probably a random set of binary that you are going to fetch from a source of randomness, such as def/random, for example. The return of that call gives you the object, the encryption object. Then you prepare your plain text message and you call the encrypt method on the plain text with some padding to make the algorithm happy, and the result is the cipher message. To decipher, you need to create your encryption engine, decryption engine again by giving again the same, the key, the CBC mode, and the initialization vector, and then you just call decrypt and you unpad if any padding was applied to the length of your message, and it gives you back the plain text. So only the first part, only the first block there is really AWS specific. The rest is pure AES encoding inside Python. Let's give you an example a bit more simple. Remember, I told you that KMS can directly encrypt for you. So you can give a piece of clear text to KMS, and it will generate the data key for you. It will encrypt the message for you and return you an envelope containing your ciphertext and your encrypted data key. So for that, you use the encrypt KMS API, and you give two parameters, the master key to use to generate the data key and the plain text that you want to encrypt. We have a couple of limitations there. The document must be quite short. It's 4 kilobytes maximum, so it's suitable to encode another key, it's suitable to encode a password, but not a long document. For a long document, you can do the encryption yourself on the client side, like I did in the previous slide. But the result of that code is to give you a binary blob, which is your cipher text. If you want to decrypt, you just get the cipher text back because it contains both your encrypted document and your encrypted data key. And so based on that, KMS can give you back your plain text document. So it's a bit simpler because you do not need to generate the data key. This is done transparently for you. And of course, you do not manage the encryption engine yourself. The encryption is made on the server side on KMS. If you want to have access to these code sample, have a look at my GitHub, github.com/sebsto, SEBSTO/KMS-demo. There is this code sample, but much more as well. One of the most requested feature from KMS when we launched was customer telling us, hey, that's great, we want to use KMS, but we want the ability to import keys that we are managing by ourselves. There might be multiple reasons to do that. One of them would be to have compliance, for example. You might be forced or obliged by compliance to use an on-prem dedicated single-tenant key management system. And if you want to comply with that, what you can do is to generate your key and manage your key on-prem using your key management service, and then export the key from your system and import it into KMS. So how does that work? First, you go to the KMS console or using the API or the SDK, and you create a customer master key, but without a key. So basically, you're just creating an empty envelope that will have a key ID and other metadata describing your keys, but the key itself will be absent from that. And once you do that, KMS will generate a pair of keys, a public key and a private key, for you to encode your key and securely import your key from on-prem. So you download the public key that has been generated by KMS, and with that public key, you encode the key that you generate on-prem. So you need to have a way to export the key from your key management system. You encrypt your key with the public key of AWS KMS, and you upload that encrypted key to AWS KMS. Upon reception, AWS KMS will use its private key, which is unique for that import operation, to decrypt your key and store the bits and bytes of your key inside the customer master key that you created before. And we have many customers that are using that. One of them that I would like to highlight, it's Moneta. Moneta, it's a retail bank in Czech Republic in Europe, and Moneta has more than 1 million Czech customer and personal and business. They have more than 3,000 employees. It's a very large bank running on AWS, and because it's bank, financial sector, they have many compliance requirements, and one of them was to manage their keys on-prem. So they are using their own key management solution on-prem, but they also would like to leverage KMS for the flexibility it gives to have server-side encryption on many AWS services. So to do that, they are exporting their key from their on-prem solution and importing their key inside AWS KMS using the procedure I just described before. So Moneta using AWS KMS to import their own key inside AWS KMS. Since reInvent last year, it was November 2019, December 2019, we also add the capabilities inside AWS KMS to manage asymmetric keys, because so far I was talking about symmetric keys when you use the same key to encrypt and to decrypt. With asymmetric keys, for each key you have actually two keys, a private key that needs to be secret inside AWS KMS, and a public key that you can, as the name implies, share publicly. So asymmetric keys is usually used to encrypt secrets, like when you want to exchange a symmetric key, or it's also used to compute signature. A signature is just a summary of your document, a digest of your document that you encrypt with your private key, and then you distribute the encrypted digest and the public key to anyone that wants to verify the signature of the document. And to verify the signature of a document, you take the document, you compute the same summary, the same digest, and you decrypt the encrypted digest with the public key of the person that signed. And if the digest you compute and the digest you decrypted are the same, then you can be confident that the document is the same, that the document has been modified since it has been signed. So with KMS now you can tell KMS to generate a key pair. The secret key stays inside KMS, the public key is public. And you can do RSA encryption or elliptic curve cryptography encryption with these key pair. Code example, also based on my GitHub example, you will find the code on my GitHub, the slide address I gave you just before. There is two new API at KMS level, KMS.sign to sign a document, and you need to pass the reference to the customer master key, except that here it has to be an asymmetric key pair and not a symmetric key pair. So here you go to your console, you create a new key pair, asymmetric key pair, you take a note of the ARN, and that's the ARN that you can give in that code sample for signature key ARN. Then of course you need to give the message to sign. There are two ways there in terms of API. Either you give the raw message and you tell the API it's a raw message, it will compute the digest for you. Either you give a digest message, so you are responsible to compute the digest and you give the digest as a parameter to the API. In any case, after specifying the algorithm you want for the signature, the response will contain the binary bits and bytes of the signature. To verify a signature, if you receive a document and a signature and a public key, you just give the key ID, signature key ARN here, you give the message to sign. Once again, it can be the original message or it can be a digest that you pre-compute already. If it is the original message, be sure to use the message type equal raw. You give the signature, of course, and the exact algorithm you want to use for the signature. It has to be the same, of course, as the algorithm that you use to generate the signature. The response object will contain a flag, a Boolean flag saying signature valid, saying if the signature is valid or not valid. That's as easy as that to use to generate signature and to verify signature with AWS KMS. Last word about KMS. Besides key management, I mentioned that already, but it's very important in terms of security and compliance. You can also define IAM policies to define who can access to your key. Of course, who can create and rotate and delete a key, but also simply who can just access a customer master key, who can generate a data key, who can generate a signature. And when I say who, it's IAM principles. So it can be a role that you attach to an Amazon EC2 instance. It might be a user, a group. So you can really get fine-grained permission for each of your application on the key management system. And every single API call to KMS is logged into CloudTrail, so you can verify in the log what are either your principals, Amazon EC2 instance, roles, user groups, or what are the AWS services that are accessing your keys, and you can verify that, so you can provide a certificate of compliance to your stakeholder to show that your implementation is indeed compliant with your security policies. So that's one way to manage keys with KMS. We also have hardware security modules available for you. If your industry or your company requires a single tenancy hardware for the keys, then you will probably choose CloudHSM. With KMS, it's multi-tenancy, so we share the same technical infrastructure, storage infrastructure for multiple customers. With CloudHSM, it's really one hardware security module that we dedicate for you. So we are going to install it in your account. I say quote, quote, install it because it doesn't involve any physical move, but the hardware security module will be wired to your account and accessible over VPC to your account. So this one is FIPS 140-2 level 3 3 compliance. Okay, KMS it's level 2 compliant. For compliance level 3, CloudHSM allows you to do that. Zero configuration, super easy to install. You can audit and use the usage of CloudHSM through the logs. The logs are pushed to CloudWatch, and you can also backup a CloudHSM. So if you do not need it for a period of time, there is no need to pay for it. You can export the configuration and the keys, encrypted of course, and then later restore your CloudHSM modules. A usage of CloudHSM also is to offload SSL operation, because the keys are staying inside the module. You can configure CloudHSM to do SSL termination for you. And it can do up to 1,100 SSL operation per second. AES encryption is at the speed of your network. You will not be impacted by the performance of the CloudHSM by itself. One single module, hardware module, can store up to 3,500 master keys. Remember, typically you are not going to use this for a data key, but for a master key. And you can cluster them, so you can group them together to create a cluster of CloudHSM module, up to 32 units inside one cluster. If you do so, you are not going to increase the storage capacity for keys, because each unit has a full copy of the keys in memory, the 3,500 keys maximum, so you will not increase that capacity, but what you increase is the throughput to do SSL offload operation or any type of cryptographic verification, such as RSA signature generation or verification, for example. In a 32-node cluster, you can get up to 30,000 RSA signature verification per second. And once again, you can scale your cluster down to 0 and restore it later from a backup. In the past, it used to be 2 separate islands. Either you manage your keys in CloudHSM, either you manage your keys in Key Management Services, but recently we integrated the two. So AWS KMS can use now a custom key store. Instead of using its own default key store, it can delegate the key store to AWS CloudHSM. So before that integration, we had really two separate islands. You have your application and all the AWS services that are leveraging KMS, that are using custom master key, that are protected by the KMS HSM baked HSM baked keys, and on the side you had your other applications that were using keys managed by a cluster of CloudHSM services. And now we have a bridge between the two, so you can tell in KMS to use keys that are actually protected by a cluster of CloudHSM. And that way the key will never leave CloudHSM and the encryption operation will happen on the CloudHSM box, but you can open to CloudHSM compliance all your applications that are using the KMS API or all the other AWS services such as Amazon S3, Amazon EBS or RDS that are using CloudHSM. Wow, that was a big part about key management. Key management is, of course, the most important part in an encryption solution. What about actual encryption if you want to do encryption from your application? I show you a couple of examples using the low-level KMS API, but we have also an encryption SDK that makes it much easier for you to manage client-side encryption inside your application. The encryption SDK is available for Java, for Python, for C, for JavaScript, and it provides you with higher level abstraction, higher level function that your application can call. It's open source, it's under an Apache 2.0 licenses, so you can do pretty much what you want with it. The key concept is that you need to create an object called a master key provider that contains reference to your master keys, multiple keys, so it's not only one. Once you have that object, you can also have an encryption context. It's a black box. We are not going to look at that. You put there whatever type of metadata that you need. And of course, you have your plain text document. And then you just call the encrypt operation. And the encryption SDK will manage the low-level details of the communication with KMS. So for example, it will create a data key for you transparently, encode your data, create the envelope to store your encryption context, your encrypted data key, and your encrypted encrypt document and give you back that envelope. And to decrypt, it's the same. You give the envelope, and the SDK will open the envelope, will access the data key, decrypt your document, and give you access to your plain text document. So where can you get that encryption SDK? It's easy. It's on the AWS GitHub, github.com/AWS-SDK-Python, Java, JavaScript, or C. Quick example in Python. I have my library imported as AWS Encryption SDK. The first thing to do is to have your master key provider object with a list of your master keys. Here it's a simple example, so I have only one master key. I put an encryption context. Once again, it's a black box. We are not looking at that. You put whatever you want there, and then you just call the SDK.encrypt method with the plain text, the master key provider, and the encryption context. It gives you back the ciphertext and an encryptor header. To decrypt, you just give back the ciphertext and your master key provider to the decrypt API method, and it gives you back the decrypted plaintext and a decryptor header that you can use. So you don't need to take care about the padding, about the algorithm, about generating data key. All of that is handled transparently under the scene for you. So it makes your code much simpler to read and easier to maintain. What if you want to store a secret, like a password, like your RDS password, or maybe an API key that you have? You can use AWS Secret Manager for that. AWS Secret Manager, it's a fully managed service to store and to manage the lifecycle of your secret. By managing the lifecycle, I mean to create, to update, to delete, but also to rotate your secret. So it uses a Lambda function to do that. So that's the best place to store your database password, for example. Let's imagine you have an Amazon RDS database with a password. You can store the password in a Secret Manager, and at application level, instead of hard coding the password inside the source code of your application, you should not do that. You can just call an API on Secret Manager to get the password and then make your database connection. And Secret Manager is protected by IAM policies as well, so you can define who has the permission to access which secret. Secret Manager can also rotate your secret. So with the help of Lambda, Secret Manager can actually periodically change the password of your Amazon RDS database and store the new password in Secret Manager. And by doing so, every time your application is calling Secret Manager, it will always get the latest password for your database. So have a look at Secret Manager to store password. RDS password is the most obvious use case, but any type of password, an API key that your application needs to call a third-party API, for example, would fit as well inside AWS Secret Manager. We still have 10 minutes left to go through network encryption and storage encryption. So let's start with TLS. We have our own library that implements TLS and SSL. So we implement that library from scratch with security as first design principle, but also we want it to be simple and small and fast. Simple because if you have less line of code, if the code is simple, it's easier to catch errors and to audit that code. So that's or simple TLS SSL implementation, S2N. You can find it on GitHub under an Apache 2 license. So you can do pretty much whatever you want with that code. And that's the code we are using to protect our API endpoint, but also your services such as the load balancer, CloudFront, and many other services that are using TLS SSL. S2N, have a look at the code. It's a C implementation, C99 implementation of the TLS and SSL standard. Talking about TLS, of course, we need to talk about certificates because you need to install, manage, update, rotate certificates on your endpoints. If your endpoints are within AWS, we have a free service that you can use. It's called AWS Certificate Manager. Certificate Manager, it's a fully managed service to provision, to manage, to deploy, to update your X509 certificate to your endpoints. And it's free to use. You can only use it for certificates that you need to deploy on AWS, so on SSL exposed endpoints, such as a load balancer or a CloudFront distribution, for example. You can also use Certificate Manager to create a private certificate authority and to start to generate certificates to validate the identity of different actors inside your organization. It might be individual users, it might be IoT objects, it might be application. So you can use Certificate Manager, private certificate authority to manage private certificates within your organization. Once again, it's controlled. You control the access to Certificate Manager through IAM, so you can have fine-grained policies about what application, what user, what roles can access, manage, delete, revoke certificates, and you can audit these access through CloudTrail. Many services, I mentioned that already, are supporting server-side encryption. So you send data in clear text to your service, and on the server side, the service are going to encrypt the data before to store the data. So data at rest will be encrypted. This is the example with Amazon S3, Amazon RDS, Amazon DynamoDB, and as I mentioned already, these services can leverage AWS KMS for the customer master key management. So you just tell DynamoDB to use a key from KMS, and DynamoDB will transparently encrypt your data and ensure that your data at rest are encrypted so that you can check your compliance box as required. What about networking? We have a lot of different options to encrypt data at a network level. For many different services, it's totally transparent for you. There is nothing to configure, we just do it, and that's an additional benefit of using AWS. So for instance that support it, we do have VPC encryption, so the link, the communication between instances is encrypted within one availability zone, within one subnet, but across availability zones as well. And that encryption is supported by Nitro. Nitro is the hardware, the virtualization hardware we have inside the physical server where your Amazon EC2 instance are running. So because that encryption is delegated to Nitro, there is no CPU overhead for your operating system, for your Amazon EC2 instance. You will not notice any CPU cycles being stolen to perform the network encryption. But because it's Nitro, it's only available on instances that are taking advantage of the Nitro architecture. You have the list as of today on this slide, C5N, G4. I will not read the entire list, but you get that on that list. It's important to understand that we encrypt both your data, so your application payload, but also our virtualization protocol, network virtualization protocol. So there is no metadata that a malicious person could exploit, such as a VPC ID or subnet ID. So it would make attacks much more complicated without these data. It's also important to understand that encryption is applied between availability zones. So it's not only within one data center, it's between multiple availability zones. If you want to get more details about that, I encourage you to read this thread from my colleague Colm that goes under a lot of different details, much more than what I'm doing today. It has also links to our documentation, so check that tweet. It's a long thread that you can read with all the details. We are also encrypting the data that is leaving a region. So if you have VPC peering across multiple regions, we do encrypt the data when it leaves a region, and we do that a bit differently than previously. We do that with specific hardware and software at the edge of our network. We call that system Blackfoot. It's like the edge service, the edge device that takes care of the communication in between the regions. So even if the traffic is going through our backbone, and all the inter-region traffic is going through our backbone except for China, we do encrypt the data between the regions as well. If you are using Amazon VPN services, you are going to encrypt your data link as well. If you are using Amazon VPN to do data center to data center, site to site encryption, it will be encrypted over IPsec. If you are using Amazon VPN for the client connection, so to connect your laptop or your smartphone to the AWS backbone, then the encryption will go through OpenVPN, which is the system we are using underlying Amazon client VPN. At the physical layer, really the cable or the optical fiber on our networks, we are also encrypting the traffic. So any link outside of our physical control, including links between data center, is encrypted, and we are using MACsec and a combination of MACsec and AES 256 to crypt the data when it's on a link that we cannot control. Once again, all the traffic between regions is going through our AWS global network, except for China. And on some links, short distance links, we also use more advanced technique like laser monitoring to detect any physical tampering with the signal. That's the physical encryption we are applying at network level. And finally, to finish my talk and going down into my lasagna slide, let's talk about storage encryption. I mentioned storage encryption already for Amazon RDS and for Amazon S3. Amazon S3, it's object storage, but we have many other types of storage. We have a block storage like Amazon EBS. We have a file storage with EFS or FSX for a Lustre system. So on all these file storage options, you have the possibility to encrypt the data at rest. Most of the time it's just a flag to enable into the console or in the API. A quick note about EBS there. If you choose to encrypt the data at rest on EBS, the encryption is done on the server side, on the Amazon EC2 instance, on the physical hardware, I should say, that hosts your Amazon EC2 instance. And once again, we are leveraging the hardware virtualization chip Nitro to do that encryption. So it means that at the time the packet is going to leave the physical hardware, so over the network, the packet is already encrypted, your data is already encrypted, and it will be stored encrypted by EBS. So the EBS service never see your clear text data. The encryption happens on the same hardware as your Amazon EC2 instance is running. And once again, this happens outside of your Amazon EC2 box on the physical hardware, so there is no noticeable CPU performance, no impact on your operating system performance to enable EBS encryption. If you were attending or following the news at reInvent 2019, you also noticed that we introduced a new family of ARM processor. It's called Graviton 2. It will be available during Q2 this year. These processors are also encrypting the data in memory. So let's imagine the worst case where someone can physically tamper with the memory of your operating system. The data inside the memory will be encrypted, and this encryption happens at hardware level inside your CPU. So there is no need to change your application or to modify your application whatsoever. So that will be with AWS Graviton 2 as soon as they are going to be available. So I told you, we encrypt everything, really everything. Beside that, we have many partners that can help you for your encryption needs. I will not read all the names that are there, but you can visit all these different partners in the partner discovery zone of this online conference. So if you have advanced encrypted need, or if you want to discover more solution around encryption, do not hesitate to visit one of our APN, one of our AWS partner in the discovery zone of this online conference. So during this talk, I talk about physical network security with laser monitoring. I'll talk about MACsec for data encryption. We talk about network layer encryption with the VPC encryption that is by default on Nitro Amazon EC2 instance, cross-region peering, and the type of encryption you can get from Amazon VPN. We also talk about transport layer and and the clean room implementation we did of TLS and SSL that you can reuse for your own application, but that we deploy on the TLS-enabled endpoints, such as the network load balancer, the application load balancer, CloudFront. And I also talk about Amazon Certificate Manager that you can use to manage your certificate for free, to the certificates you're going to deploy on your SSL endpoints. And we start the talk with a long conversation about key management with AWS KMS, with AWS CloudHSM, and the various options you have to interact with these by code, either by using low-level AWS SDK or higher level, the AWS Crypto SDK. I hope I learned you a few things during this talk. Thank you for watching until the end. If you have any questions, do not hesitate to reach out to me on my social media account, Sebsto on Twitter, SEBSTO. SEBSTO. Talk to you very soon. Thank you.